Here's number one in your review. This is a combustion analysis, again, trying to figure out the formula of this compound. So we need to know moles of each of these things to get the formula. So they burn this. In oxygen makes carbon dioxide, makes water. Again, all of the carbon from this went into this. All of the hydrogen from this is in that. So you need to figure out how much carbon's in this, same as the carbon in that. How much hydrogen's in this, same as hydrogen in that. Then we can get oxygen, get our stuff from there. So we have 12.24 grams of carbon dioxide. For every 44 grams of carbon dioxide, that's a mole off the periodic table. It contains 12 grams of carbon. We do that, you get 3.34 grams of carbon, 2.505 grams of water, and in 18 grams of water, there are 2 grams of hydrogen, 0.278 grams of hydrogen. To get oxygen, so 3.34 of these grams are carbon, 0.278 are hydrogen. So subtract these two out of that. So I'm gonna take 5.287 minus both of these and get my grams of oxygen, and the grams of oxygen at being 1.67 grams of oxygen. So there's all the grams that are in that. Turn these into moles, so divide this by 12, divide this by 1, and divide this by 16. Again, those are just the mass off the periodic table to get moles. So carbon's moles are 0.278. Hydrogen's moles are also 0.278, so we know those are a 1-to-1 ratio. And oxygen's moles are 0.104. Divide them all by the smallest, so divide by 0.104. Divide by 0.104 is about 2.67. And divide by 0.104, 2.67. Well, we can't write C 2.67, H 2.67, and 1 oxygen. If I double that, that doesn't work out. But if I triple this, take it times 3, that does give me a whole number, gives me 8. So take all of these times 3 to get to whole numbers. So we end up with 8 carbons, 8 hydrogens, and 3 oxygens. So our formula would be C8, H8, O3.